Find the currents flowing in the circuit in the figure below. Explicitly show how we follow the steps given in the problem-solving strategies for series and parallel resistors. Alright, so now we have three different branches here. Let's break it to different branches. You know, here we have current flowing from the upper loop through the three resistors. So we can combine these three resistors. Let's call it branch number 1. With the same token, we have current through internal resistance R2 and R1 is the same on this one branch. So let's have this branch. Let's call it B2. And the third branch here is the lower branch, that is R3 internal resistance 3 internal resistance 4R in series, and this branch here. Let's call it branch 3. Now, since these branches are in series, we can combine the resistors together. So, what is the effective resistance of the first branch? The effective resistance of the first branch, let's call it RB1, is equal to resistor R1 plus resistor internal resistance R1 plus R5. Alright, so R1 is 5 ohm and our internal resistance R1 is 0.1 and R5 is 20 ohm. The sum of all these three is 25.1. So three resistors are in series. Alright, so let's do the same thing with RB2. What is the effective resistance of branch number 2? The green one. So we have internal resistance R2 and load resistance R2. Plug in the numbers. Our internal resistance is 0.5 ohm and the load resistance R2 is 40 ohm. And the series of this second branch has an effective resistance of 40.5 ohm. Let's do the same thing with the third branch, RB3. In this third branch, we have resistors in series, which are R3, internal resistance 3, and internal resistance 4. Plug in the numbers. R3 is 78 ohm. Internal resistance 3 is 0.05 ohm. Internal resistance 4 is 0.2. And they are at 78.25. All right, notice here we have internal resistance 4, not load resistance. Okay, so now we have three effective resistance of the three branches, so we can simplify our circuit. And doing that, let's start with E1. So let's have our circuit. Simplified circuit will be with E1 and then RB1, second branch we have E2, RB2, now third branch we have two sources in the third branch, and the first one is positive here and negative here, and this is RB3. Then we have the second source, which is positive here and negative here. Alright, this is E4. This is E3. So our circuit is simplified like this one. So we represent each branch with its effective resistance. Alright, now that we have a simplified circuit, so we also said this is going to be I3 conventionally, this is I2, and this is I1. Now this is assumption. We don't know the direction of current yet, but we assume I3 to go up and E2 to the right, E1 up. This is just an assumption. Once we get the results, if it contradicts our prediction, if say for example I1 is negative, then we reverse the direction. Alright, so let's start doing the calculations now. Let's start with junction rule. So junction rule says, Kirchhoff's junction rule says, the sum of current entering a junction is equal to the sum of current leaving the junction. So in our case, E3 is going to this junction, and I1 and I2 are leaving the junction. And that means I3 is equal to the sum of the currents leaving, I1 plus I2. Let's call this equation number 1. Okay. Second is to use loop rule. Let's assume the loop to be in this direction. We can assume counterclockwise, we can also assume clockwise. So in my case, I'm choosing loop 1 to be clockwise. I can do the same thing with loop number 2. It's arbitrary. I can use counterclockwise or clockwise. For simplicity, I'm going to use this loop here, clockwise again, loop 2. Right, so we have loop 1 here, in this direction, and loop 2 here in this direction. Alright, so let's do the loops now. Loop 1. Loop 1, let's start from E1. E1 goes from negative to positive, therefore it's going to be positive. So in the electromotive force, from negative to positive is positive. Now we are crossing RB1 in the direction of current. That means we are dropping, and that is negative I1 RB1. Okay, so now crossing RB2 in the reverse direction. I2 goes into it from left, they are crossing it from right. Therefore, it will be positive. That's I2, RB2. Alright, and then we are crossing E2 from positive terminal to negative terminal. That means we are dropping. So an electromotive force, if you are moving from or traversing it from positive to negative, it is negative. Therefore, this is going to be E2. That add up to 0. Okay, let's simplify this. Let's add E2 to both sides and subtract E1 from both sides. And that yields us negative I1 RB1 plus I2 RB2 equals to E2 minus E1. Alright, so we can rearrange this for I2. So I2 RB2 equals to E2 minus E1 plus I1 RB1. Therefore, we can write I2 in terms of I1. I2 will be equal to E1 as E2 minus E1 plus I1 RB1 divided by RB2. Let's plug in the numbers. E2 is 48 volts. Minus E1 is 24 volts. Plus I1, which is unknown, but we know RB1. RB1 is 25.1. Ohm times I1 divided by RB2. And RB2 is 40.5. And that yields 24.5 volts plus 25 I1 over 40.5. So now we know I1, I2 in terms of I1. Let's call it 2. Okay, let's do the same thing with loop number 2. Alright, for loop number 2, let's start from E2. So E2 is right here. So E2 is positive from negative to positive terminal. And we are crossing R2. and that's RB2, and times I2 minus E4 from positive to negative. They are crossing E3 in the reverse direction, so from negative to positive, that's going to be plus E3. What else is missing here? We are missing I3, that is I3 RB3. Should add up to 0. Okay, rearranging, taking E4, E3, E2 to the other side. E4 becomes positive, E3 and E2 will be negative, and therefore we can rewrite this as minus R E2, I2, plus as minus I3, RB3, equals to E4, which is positive now, minus the sum of E2 and E3, which were positive on the left side, E2 plus E3. Okay, so now we can plug in the numbers. RB2 is 40.52, or just multiply by negative number, and that yields RB2, I2 plus I3, RB3 will be equal to E2 plus E3 minus E4. Okay, let's take it here. Alright, so let's plug in the numbers. And that's going to be 40.5 I2 on I2. That's for RB2. Plus I3 RB3, therefore it's going to be RB3 is 78.25 ohm I3 is equal to E2 plus E3 48.0 volts plus 24 volts. E3 is actually 6 volts. And minus 36 volt, which is E4. Okay. So we have 40.5 ohm I2 plus 78.25 I3 . So now instead of I3, we can use I1 plus I2 because I3 is equal to I1 plus I2. And 48 plus 6, 54 minus 36 is 18. So this will be 18 volts. Okay, so now I have I1 and I2 here. We have I2 here. We can combine them. So we have 40 I2 I2, okay, and plus 78. So we can combine the I2s together. So 40.5 I2 and 78.5 I2. Therefore, this is going to be 78.25 I2 plus 78.25 from I1 is equal to 18 volts. So combining the two will give us 40 plus 78.25 is 118.75 ohm I2 plus 78.25 ohm I1 equals to 18 volts. Okay, so now we know I1 and I2 are related, and we said I2 is equal to 24.5 plus 25.1 I1 divided by 40.5 ohm. So we can substitute I2 by that. Therefore, this is going to be 118.75 ohm. Instead of I2, now I can write down 24.5 volt plus 25.1 I divided by 40.5 ohm. Now we have plus 78, this one here, 78.25 volt. That all equals to 18 volt. Okay, so we can divide 118.75 by 40.5, and that yields 2.93 into 24 volts, 24.5 volts plus 25.1 I1 and that is equal to 18 volts. Okay, therefore I1 will be equal to 18 volts minus 2.93 times 24.5 is 70.32, so that's going to be 70.32 volts. Divide that by 2.93 times 25, which is 151.8. That yields negative 3.45 That's this value here. So now we know I1. Okay, so it shows negative, indicating that the direction we assumed was wrong. Therefore, direction of the current I1 is actually in this direction. So what's I2 going to be? I2 is going to be, because you said I2 is equal to 25.5 plus 25.1 I1 divided by 40.5. You can just plug in the numbers. I2 will be equals to 24.5 volt plus 25.1. So now instead of I1, I can write down negative 0.345 amp. Divide that by 40.5. And that yields 0.379. Okay, that's I2. Now what about I3? We said I3 is equal to the sum of I1 and I2. Therefore, I3 will be I1 is negative 0.345 amp plus I2 is 0.379 amp. That will be equal to 0.034. That will be I3. So I1 is negative 0.345, I2 is 0.379 amp, and I3 is 0.034 amp. And that means current flows from the upper loop towards the junction with current of 0.345, and current I3 enters the junction with a value of 0.034 amp, and E2 will be the sum of these two, and that will be equal to 0.379 amp.